process of the Industrial Revolution is not stopped. It's keeping going. And nowhere is this more obvious than in computers. If you look at your iPhone, you have more computing power in your hand than the Navy had in 1980.
Energy abundance, I agree, is not necessarily obvious, mostly because we take energy for granted. We don't see it, feel it, live it in our day-to-day.
I don't like the word consume more electricity. I think efficiency is important, but we shouldn't stop what we're doing and go focus on efficiency. We also shouldn't try to just scale up consumption. We should try to do great things, right? To go places we've never gone before, to really understand our place in the cosmos. And we shouldn't ever be limited by energy. We should increase our production of energy, pacing population growth. Every time there's a massive efficiency boost, that's a big gain and benefit. And we should be spending to make that happen.
Right now, something like 50 million people worldwide enjoy the benefit of being able to jump on a plane, fly around the world. This is an incredible privilege. So if we 10x the amount of energy being consumed in aviation, right off the bat, that's 500 million more people are able to fly. So basically you take that curve, you lift the ceiling, and everyone else gets brought along behind. And maybe one day we'll have a world where 8 billion people can jump on a plane and fly around.
I think abundant energy on Earth would solve many of Earth's problems here today. If you have enough energy, you can fix the environment. You can remove carbon from the atmosphere. You can create habitable environments for species that are threatened. Being able to actually produce hydrocarbons cheaper than you can refine oil is probably the most important technological unlock of the 21st century. If we can actually produce abundant hydrocarbon fuels outside of oil and gas, we would literally decarbonize the entire economy overnight.
The kind of projects that we could build as a culture are just expanded to media. We could begin to actually do the space things that we had thought about in the 60s, thought we were going to be doing soon. We could actually go and try and colonize Mars, for heaven's sake.
I think an energy abundant future means that we have access to technologies that today only the very, very few elite research institutions or Nobel missions have access to. So that means the rate of technological progress will accelerate at orders of magnitudes that we have not seen before. The level of infrastructure required for basic human functioning and for us to integrate technology in our daily life will just become, something we don't think about.
If you have unlimited quantities of cheap energy, it is crazy to do anything else, right? Because then you can literally start with any raw material you like. Like right now, if you want to create humans, first of all, you have to start with a bunch of hydrogen, and then you have to collapse it into a star, and then you have to form a planet nearby. No, wait, there's another step. That star has to die and produce more elements that then explode outwards. And then they have to come back together and form another star and a bunch of planets. And then those planets have to get life. And then the life has to chug along for a while and eventually absorb photons for a few billion years and then emit a Tesla and some people and stuff like that. But if you have infinite energy or the ability to transform between different kinds of energy in effective ways, you can literally start off with hydrogen or rocks or anything you want and convert it to any other thing you want.
I do think you can imagine a world where things, you're living in spaces that are extremely high functioning, dense, clean. Think of all the jobs you could have robots doing. You can free up humans to work on other creative pursuits. And I think that's, a beautiful world where humans can be doing what humans do best and leaving some of the rote labor to energy can power those sorts of technologies, robots and other things.
I think the future of humanity as we go forward is sort of like a conductor or a composer. So if you think of AI at your fingertips, even now with ChatGPT and some of these LLM models, you can sort of tell them to start doing things, and directing them generally on what you want them to do. And that costs a lot of energy. So we need to produce a lot more energy. But as these things advance and as it starts getting connected to robotics, you begin to actually craft narratives about how you want the physical world to look. And the AI does it for you, and it consumes energy, and it uses robotics. And we become sort of these conductors or these artists with the physical world as the canvas and outer space as the canvas. And we create these beautiful cities, I hope.
I think that looking back on a more cosmic timescale, on a geological timescale, we're going to explode off this planet. And that's going to create a much bigger sphere of influence for humans, a much bigger place for us to use energy, a much bigger place for us to explore, to enjoy, to satisfy our curiosity. And energy is going to be a part of that story. We're going to have nuclear powered rockets, zipping around the solar system so that, we don't have to wait for the planets to line up and launch to Mars every 2 years. Just go anytime you want.
Space travel is interesting to me. I guess I'm more interested in what you do when you get there than I am at the propulsion aspect of it. So like for the moon or for Mars, I'm really interested in like megawatts of power, harvesting and bringing resources up and producing things. So Mars is like this planet where like the surface layer is just dust that's been mixing for a few 100 million years. It's all really random, right? It's all mixed up with itself. So it looks the same wherever you go and you measure it. But a couple of places we found, like, I think there was actually just like a nearly totally pure sulfur rock found on Mars. And one of our rovers had locked its wheel, I think the Spirit rover, and it dragged this wheel and uncovered this like bright white patch that it found on its mast cam. And so the NASA scientists had to go back and take a sample, and they found like 96% purity silicon dioxide on the surface, which is glass. I want to see construction vehicles, and those need power too. So like maybe even more than propulsion, I'm more excited about big machines, moving big amounts of material and like mining, producing millions of tons of goods at really high purities, which maybe is like the ultimate measure of how civilized a planet is.
I think with infinite energy, definitely, I think we can become a multiplanetary species. That's just because, now we can power things. Ideally, if they're location independent, then you can, go to the moon and go to Mars and build like energy bases and power all the research and technology required to get there. So, I'm very excited about that.
We're manufacturing in space. We're colonizing celestial bodies. Our ability to travel between those celestial bodies is accelerated. Even here on Earth, our ability to traverse the Earth accelerates by a factor of 10, that is. What if we had commercial hypersonic travel available to us today? You could even imagine a world where we use space launch as a way to navigate the Earth, right?
There are antimatter particles that humans can generate through known sets of physics reactions, including some of those that occur in a fission reactor. So like a 3.5 megawatt thermal reactor generates about 27 kilowatts of antimatter continuously while operating, like antineutrinos that shoot off through the Earth and everything else and just go out into the forever of space.
There's the concept of an O'Neill cylinder, for instance, is this really fascinating thought experiment, which is what if you created a giant floating cylinder out in space and rotated it at the right speed to create artificial gravity and pointed it at the sun so that you have some sunlight coming in? And could you create a human civilization that's essentially floating out in space? And what's interesting about that is it's somewhat infinite, right? If you can create one O'Neill cylinder, you can create 1,000. And what do each of those do? Well, they have factories inside, and the factories are producing things, but they're not using human labor, they're using robots. And those robots are consuming energy from nuclear reactors. Once you start to really understand the constraints of that system, you can see that it's truly infinite. As long as we have access to energy, and as long as we have access to physical material, we can truly create whatever our minds imagine. And that's a very exciting future to me.
And like many of my peers in the space that are very excited about space travel, I'll let them have fun with that. That's not my thing. I like to think about just like, how can we make life on Earth so comfortable and so luxurious for everybody? And so that involves just 10xing so many of these things that we think of as normal in upper society, but that other people still don't have regular access to. And so that's really where my focus is.
The really exciting thing for me about this is that it allows us to be even less thoughtful, even more productive when it comes to performing the processes that we need to interconvert between different kinds of matter. So like right now at Terraform, we are sweating bullets trying to figure out how to convert sunlight and air into fuel at a price that makes sense for our consumers. Right? It's like, if it was easy, people would have done it. It's just possible. But if energy is 100 times more abundant and 100 times cheaper, then we don't have to be quite as careful in how we use it.
The bottom line is, I'm looking at another industrial revolution that multiplies everybody's standard of living by another factor of 100.
As long as we have access to energy, and as long as we have access to physical material, we can truly create whatever our minds imagine.
Energy is going to be a part of that story.
Energy is what makes us human.